Hi, I am MD Russell Lincoln. Our project is basketball game activity recognition, and here are the topics that we will be presenting today. In our project, we have used the three sensors to collect the data for our five activities. The left ear sensor giving us accelerometer and gyroscope data in X, Y, and Z direction. Wrist and ankle data are giving us only accelerometer data in X, Y, and Z direction. We get raw data from sensors, then we do pre-processing where we combine all the data in then in segmentation we divide the data into small groups. Then those small groups of data are passed to our neural network, convolutional neural network, which is CNN. And in data pre-processing, we are actually eliminating all the uncommon measurement of a sensor with respect to time. That means we have the same start and end time of all the sensors. After that, we label the data of each activities by watching the start time and end time from videos. And extra data will be mentioned as a null.
As my colleague mentioned, our data is recorded continuously with respect to time. Because of that, segmentation of data is a necessity. To do that, we use sliding window algorithm. Each of these windows has 12 columns. Each column represents one of the sensor measurement, and it's labeled by last measurements of the label, last measurement label. Each one of these windows passed into convolutional neural network. This network include two layers as convolution layer and two linear layer and one output layer. To measure the performance of the system, our model, we use four-fold cross-validation, where three of these folds used for training and the fourth one used for testing. After that, we repeat this process over all the folds, as the slide shown. At the end, we use the average of the F1 score, uh, and that number will, and that average will represent the whole model performance. Uh, to test our model performance, we adjust some parameters for sliding window parameters, shuffling of the window, modeling structure, and number of the classes. In the sliding window parameters, we focus mainly on length of the window and on the labeling of the window. For our project, we choose the window size as 1 second, which provides the network by good pattern of the activity. And we took last activity label. In addition, shuffling of the window is important to prevent the overfitting of training data. In this project, we could use 1D convolution network or 2D convolution network. Though the 1D convolution network is better because in case we use 2D convolution network, it will do the convolution over several sensor measurements, which will merge different sensors and degrade the performance of the whole model. As we mentioned earlier, we have 5 classes and null. If we ignore the null, classes, the model will have better performance for our training and testing data, as left figure shown. But on the other hand, the network won't work well under real-world application because it can't decide the null activity, which anything outside of our specific activity. In conclusion, getting F1 score above 90% is possible if the previous adjustment took into consideration, as this table shown. For more details, please check our project in GitHub. Thank you.